So, good morning, all. Welcome to the webinar series organized by C-DAC Patna on artificial intelligence and data science. In that series, this is our day 5, and we have with our expert, Mr. Kunal Shah. To explain his profile in a brief, he has 20 years of diverse career graph with rich experience in leadership, AI, data science, with previous experience of cloud platform, IT security, IT consulting, business development, account management, and leadership. He has previously worked with giants like Teradata, CA Technologies, and senior security consultant. And C-DAC I hope it is both ways, as C-DAC is also fortunate to have collaboration with Kunal Shah sir as an expert trainer of AI and data science in our PG diploma courses. Kunal Shah, we can start now. And if you can check I think you are able to present now.
Yes, I am able to present.
Okay, sir. Over to you, sir.
Okay, thanks, Saket. Thanks for the. All right. So thanks, Saket. Thanks for the introduction. Good morning, everyone. My name is Kunal Shah, and Saket has briefly introduced me about my experiences. We have around 2 years of collaboration together with C-DAC. And when Saket invited me for this webinar, I wholeheartedly accepted because primarily for the reason that I'm very passionate about this field. Even though I don't have any formal background in mathematics or statistics, as Saket said, I graduated almost 20 years back, but it's only because of my passion I picked up really well in the last 6 to 7 years. And every time I get a chance to share my knowledge or information, or at least talk to someone about the AI or machine learning, I don't miss that opportunity. So my idea here is that in the next 30 to 35 minutes, I just want to explain you what the artificial intelligence is and how have we arrived where we are in terms of the artificial intelligence now, and what kind of opportunities that business are leveraging. I will also try to get into a little bit of detail of what kind of teams that we are seeing in artificial intelligence today when we are executing the projects and things like that. So at the end of the session, my idea is to give you some overview of how the artificial intelligence is being used in the mainstream business nowadays, and what kind of teams that all these projects are running, so that if you are planning to build your career in artificial intelligence, you should know how and what kind of roles and responsibilities that people are looking for. So with that, let's start with some little bit of the introduction and the background of artificial intelligence, right? So the concept of thinking machine is not new. I mean, all the way back in 1842, even before the computers were invented, people already started to think of building the machine which can do beyond just pure calculations and do something which is very much resembling to what the humans can do today. So you guys must have heard of a lady called Ada Lovelace. She is an English mathematician, and Charles Babbage is a very popular name. He's the first one who actually built a mechanical computer. But the very first mechanical computer that they built was only difference engine. I mean, it was purely a calculator. And Ada was the first one to think that that computer can definitely do more than just pure calculations. It can do something more, which can think. And it seems that she was the first one who actually wrote the first algorithm to run some analytical operations using that particular machine. And together with Charles Babbage, they came up with something which called the analytical engine. So the first computer that Charles Babbage developed was difference engine, and in 1842, the first analytical engine came into the picture. And many people think that Ada Lovelace is the world's first computer programmer, right? And the idea was that ever since the idea generated that there is a machine which can do the calculations and computation and things like that, there is always a kind of a hunger to make sure that this computer can do even better. It can kind of mimic what the humans can do, right? And since 1842, AI has been thriving field for many practical applications and active research topics. A lot of various flavors of artificial intelligence has been evolved. It started with something we used to call cybertronics, then it went to things like expert systems and stuff like that. And most of these fields had their own ups and downs. So they started with a particular research in AI, and then eventually it died down because either the computation facility was not available, or it was very expensive to do that computation, or even the data. We never had that much of the data that the AI systems needed to be better. And it was in the 1985 onwards when the new algorithms developed, the advent of the digitization of most of the transactions that we have today. We got a lot of data. The computation power became extremely cheap, and the AI field or the AI research that happened during that time has a very profound impact on a lot of business applications that we see today. Right. So in early days, people think that the AI can solve many problems that are, sort of intellectually difficult for human beings, but relatively very straightforward for computers, right? So if you have a very complex calculations to do, let's say if you want to calculate, an income tax for something or something, these are very complex calculations for the human being, where a lot of equations are involved, a lot of numbers are involved, and they are usually difficult for human beings to do, but they are relatively straightforward for the computers, right? If you can explain the problem using just a list of formal and mathematical rules, then the computers can even do it better than the human beings, right? But where the real challenge came to AI is to prove in solving the tasks that are very easy for people to do, but it was very extremely difficult for people to describe formally, right? Like recognizing the spoken words or identify the face. How can you explain how are you identifying a face, right? If you know me, and if you're meeting, your brain immediately figures out that the face that you are seeing is Kunal Shah, or even now many people that we know may be able to recognize me on the video, that this is Kunal Shah's face, which is who is talking. But how do you explain that? How are you inferring that this is Kunal Shah's face? This thing is evolved in our biology, and it's very easy for people to do, but it's extremely difficult for AI to do, right? And that's what has become the real challenge for AI, right? So what exactly that particular challenge is, right? I mean, we there is a very common chart that is being shown about what the AI is, and it's a kind of a mixture of a lot of algorithms, what are a lot of different ways of learning from the data and things like that. And this particular chart was very popular when Ian Goodfellow, who is one of the very good researcher in deep learning with Facebook and other organizations, had come up with something like this. And this actually shows what the AI comprises of, right? So AI is a kind of a huge field, and then you have this expert knowledge, which is the example, the knowledge base, which is the example of the AI. And then there is a little bit of machine learning happens in the artificial intelligence, which usually you do things like logistic regressions, which is drawing a straight line across the data. And then comes the representation learning, and the deep learning and things like that, right? And it seems that there is a better way to represent the entire thing, and it is through this, right? So basically, these are some of the ways you can do the artificial intelligence. So, for example, the rule-based system is where you simply specify a rule, right? So for example, if you say y is equal to 3x plus 2, right, or 2x plus 3, what you are actually telling the computer is that I have hand designed this particular rule, and now if I give you a different values of x, right, you will be able to tell me what are the values of y, right? So that's a very straightforward computation that most of the computers are able to do, right? But what the classical machine learning came out with is that instead of me telling you what these rules are, I want you to figure out what exactly these rules are, right? So in that case, what I'm going to do is I'm going to simply tell you that when my x is 0, my y is, let's say, 3, right? When x is 1, my y is, let's say, 5, right? When x is 2, my y is, let's say, 7, and so on, right? I mean, what you are actually doing is that you are telling the input and output to the computer, right? Where and these inputs and output is what we call the features, right? So we are actually designing these features by hand. We are not saying what the rule that the computer should use to arrive this. And what we are saying is that my program should automatically figure out what the rule that I should be applying here. And from this, it's pretty straightforward. Your computer will do a number of operations in that and say, well, from the data that you've given to me, it looks like your rule is something like y is equal to 2x plus 3, because when your x is 0, your y is 3, or when your x is 1, your y is 5, and so on, right? So as you give more number of features, right, which is x and y, the computer will be able to learn these features by mapping these rules with these features, and then give you the output that according to me it looks like your equation is this. And next time when you will give any x for which the y is not known to you, your computer will easily tell you what the y should be, right? So that's what usually happens in classical machine learning. But then there is some more needs arise. There is some more stuff needed to happen. For example, there are situations where it is not actually possible to give this kind of handwritten or hand designed features, right? So for example, if you want someone, if you want to write a program where you want to say, this is an eye, right? Or recognize a picture, and in that picture you are saying that recognize where the eye is, or recognize where the nose is, right? There is no straightforward mathematical equation which you can use, which will tell you that how these I don't know how the just give me 1 minute. Something is wrong with the presentation. Yeah. So so you can't specify, what is the equation for I, and in that case, what we are actually asking our artificial intelligence to do is, representational learning, where we are saying that you learn the feature yourself. So I'm not going to tell you what is the x and y in my data. You figure out yourself, and that's where the deep learning was invented, where the feature itself is being learned from the data, and then again the mapping happens between the features and the output, and the output is predicted, right? And if you take the complexity one notch further, you get something which is the deep learning, where you initially start with the simple features. So you initially start with something like eye or nose and ears and things like that, and then you keep putting additional layer on top of it. So you can say, if you see something like which has 2 eyes, 1 ear, 1 nose, then it represents a face of a human, or the cat's face looks like this versus a fish face looks like this, and things like that, right? So you take the simple features, you start building on top of the layer on top of that, and that's what the representation learning or the deep learning. And together all these, I mean, in your artificial intelligence system, you will use one or more these kind of techniques to identify what exactly your business problem that you're trying to solve, right? So that's what the different ways of doing the AI. Now there is a lot of excitement about AI, but at the same time there's a lot of hype about it as well, and that's basically the AI that we know today is not actually just a one thing. The AI that we know today is actually two separate ideas. So one is what we call the artificial narrow intelligence, right? The artificial narrow intelligence is something that we actually see nowadays all around us, right? So your Alexa or your Google Home system, or even the smart driving cars that you are seeing today, or anything, factory automation. Your entire factory floor is automated. I mean, if you go to places like Taiwan and China, if they have a 3-4 kilometer long factory floor, which is completely touchless, right? The humans are not allowed in those factory floors, and entire thing works with IoTs and artificial intelligence, where the machines can talk to each other. But all these things comes down to a specific branch of artificial intelligence called the artificial narrow intelligence. And these types of AIs are usually one-trick ponies, but if you find the appropriate trick, then these can be extremely useful, right? So the spam filtering, the automated factories, the Alexa, I mean, these things are very good at what small things. You can ask Alexa to tell you a joke, or check your bank balance and what the time is, or set up the timer and things like that, right? And we are seeing a lot of progress in artificial intelligence, right? I mean, if you see the way Alexa has evolved, or if you see the smart driving has evolved, Tesla and all, we saw a tremendous development in progress in this particular field in last 7 to 8 years. But at the same time, there is another branch of artificial intelligence which is called artificial general intelligence, right? And this is the actual goal of the artificial intelligence, where we are trying to build artificial intelligence to do things which humans are able to do, right? So anything that the humans can do. And unfortunately, not a lot of progress has happened in this particular field. And primarily, the reason for that is we need a superb technological breakthrough to understand how the human brain works. The human brain is evolved over millions of years of evolution, and the kind of neural network that we have inside our brain, even from the biological standpoint or from the psychological perspective, we know very little about what our brains can do and how they are doing certain things that it is doing today. So we definitely need a significant technological breakthrough before we can say that that we are going to design something like superhuman and things like that, right? But even after that, there is a lot of hype. People are worried that the robots will take over the job, or there will be some a Terminator kind of an army which will take over the world and make all the humans slave and things like that. I don't see that happening in at least in my lifespan. I think we are almost like 100 years, if not at least few decades away from that happening, because as I said, it needs a lot of a technological breakthrough for us to do that. Now the problem is that many people think that whatever the progress that we made in artificial narrow intelligence, the same progress that we made in artificial general intelligence, and that's the hype, right? And that's the hype I'm talking about, and that is not true at all, right? The other issue also that we usually see is in the media, right? I mean, if you read the journals and all those things, most of the time what we will see is a success stories about the artificial intelligence, that okay, researchers did this, researchers did that, etc. But you will never see the failures of the artificial intelligence, right? There is no publications which publishes that researchers were trying to do this and they couldn't do this, and they are back to, drawing board, they are back to square one, things like that. So people have this false sense of opinion that artificial intelligence can do anything. Now, the one thing is that there is a hype, there is kind of an insecurity that, artificial intelligence will take over the world and things like that, which is completely unsubstantiated, right? There is no base to it. But then when the same kind of a perception that the artificial intelligence can do anything comes into the business, a lot of business fail there, because what we started to see is that most of the CEO try to figure out that, okay, if artificial intelligence can do anything, then let's go ahead and start an artificial intelligence project in our office or in our company. They do that, even without doing some due diligence that, whether it is going to be useful to them, or is it going to make their life easy, or is it going to make their company better, or is it even required, or even more, is it even feasible to do that, right? I mean, so that false sense of security that artificial intelligence can do anything can have an adverse impact on your business, right? So even after going through a lot of seminars and all, if you have a sense of understanding that artificial intelligence sounds very interesting, and it's in future it's going to do absolutely everything, that is not true. And in this session, my intention to tell you what artificial intelligence can do and what it cannot do. Right. So as I said, the media will only tell you what artificial intelligence is able to do, but they will never tell you that we tried this and we failed and we are not able to do that. But in this case, I am intending to give you a very simple and short answer to that particular question, as if what artificial intelligence can do, what artificial intelligence cannot do. And that's a kind of a rule of thumb which I used in my practical life every time. So, part of my job is we provide consulting to a lot of businesses when they want to adopt artificial intelligence or machine learning in their core business activities. And we go to them with this particular rule of thumb, right? So every time I get a call and say, hey, we are trying to start this new project in artificial intelligence, can you come and consult us and help us delivering, right? So the very first thing that I do is, do that particular due diligence, right? And the very first question that I ask is this, whatever is that you're trying to do, are you, as a human, can you do that without giving 1 second of thought, right? If there is anything that you can do without giving a 1 second of thought, now or soon, we are going to automate it using AI, right? So, for example, if I ask you to tell me a joke, right, you're not going to take a second to do that, right? It's a quite obvious for you to tell me a joke. And if that is the case, then we can definitely automate that. And that's what, the smart speaker systems like Alexa and Google Home and all those things have done, right? Even driving for that matter, right? You are not actually thinking, you are not giving a thought before, pushing those brakes. It's quite intuitive to you that if there is a vehicle in front of you and if it is slowing down, the very natural thing that you will do is you too will slow down. And if it is stopping, or if you see a brake light, you will also slam the brakes, right? Now, you may not have thought about it, before I just told you so, right? How are you applying a brake? You are not even thinking about it. You are simply seeing the brake light in front of the car. Brake light in the car in front of you, and you're slamming the brake. You're doing it without a second thought. And that is one of the reasons why we are able to design things like smart cars, right? But then there are certain things that the smart cars are not able to do, right? I mean, if I'm driving a car and if I see someone 100 feet away who is showing me some sign, I will take more than 1 minute to realize that whether he is trying to alert me for a danger that is in front of him, or he's trying to ask for a lift, or he's trying to tell me something else, like, I have a flat tire or something like that. I can't do that in a 1 second of thought. And that's exactly the problem we have even with the smart cars today, right? So smart cars are not able to figure out the human science today that the humans are doing on the road, right? At the same time, if there are a specific sign, the road signs that the authorities have put there about the speed limit or speed break or something like that, the smart car will definitely will try to figure out, right? So anything that you can do without giving 1 second of thought. If you are seeing an email without giving a second of thought, you are saying this is a spam, right? Even the speech recognition, right? I mean, you know who is talking, you know whether this is a male's voice or female's voice and things like that, right? So all these things that you can do without giving a 1 second of thought, sooner or later, we are going to automate that using AI. And you can very well put this to the test. I have always tried to put this to the test every time I go in a business meetings and every time someone is starting a particular AI project, right? And at the same time, AI cannot do something that human takes a lot of long time to do, right? If I ask you to recite me a poetry, you cannot do it in 1 second. If I ask you to, tell me a specific incident about a specific subject, you cannot do it within 1 second of thought, right? So these are the things that the AI is not able to do today. AI cannot analyze a company and write a 50 pages of report to, or even address the customer grievances and things like that, right? So let's take a concrete example of the customer grievance, which is something that we actually worked out while having a business meeting with one of the insurance companies. So the insurance company was trying to figure out, can we go through our customer grievance data and figure out which customer is happy and which customer is not happy. And that customer grievance data could be the emails that the customers are sending us, the tweets that customers are giving us, the phone conversations the customers have with us, even the customer retention cycle that we see, etc. Right? Now, I cannot go in a lot of detail about how I design that solution for them, but I can give you something very much relative to that, and that is, let's say, in customer support, let's say you receive an email from the customer that my order arrived 2 days late. I couldn't gift it to my daughter for her 10th birthday, right? Can I return it, right? Now, when you look into this email, without giving 1 second of a thought, one thing that you can do is you can immediately identify that this customer is asking for a refund, right? You can also figure out that this customer is not happy, right? So what we can do is we can definitely build an AI system which will classify this particular email and put it in a proper queue. Obviously, the AI system itself is not going to process the refund. There is another group which is going to do that. But I need to, so far what used to happen is someone manually goes through this email and try to figure out which particular queue that I redirected to, which particular group I should send this particular email to. Instead of that, we build an artificial intelligence system which can at least identify that this has something to do with the customer grievance. He is not happy, number one. We still don't know why he is not happy. The AI system still doesn't know why he is not happy, but from the tone of the email, it looks like he is not happy and he is looking for the refund. So the one thing that I can definitely do with AI is I can redirect this to two different groups, where one is taking care of the customer satisfaction and one is taking care of the refund, right? But and that's what we are seeing right now. A lot of AI chatbots that you are seeing is doing the primary, what we call the zero level support, where it is trying to figure out what exactly your queries are and where exactly I should redirect you there, right? But what it cannot do, right? What it cannot do is write something like, oh, sorry to hear that. I hope your daughter had a good 10th birthday. You can definitely return it. Let me, process your refund. Now these kind of emails are very, very subjective. They are very, very personalized, right? Because you are actually responding to this particular person. You are not responding using an automated, system saying we received your email and will respond back in 10 minutes or something like that. You are actually trying to connect with this particular customer. And that's something that you cannot do with 1 second of thought. You have to read the email. You have to, you have to think what you want to respond to this, and then you draft a response to this, right? And that's something that, your AI chatbots cannot do today, right? So what makes the AI project feasible, right? So this is one of the classic examples where we sit before the project starts, and we say, well, this is what your AI system will be able to do, and this is what your AI system will not be able to do, right? So basically, what makes an AI project feasible? What we learn from this is that so far, if you are teaching a very simple concept to your AI system will definitely perform well. And those simple concepts are sorting out the queue or recognizing the handwritten digits and things like that. So if you have a address recognitions and text recognitions and things like that, as well as if you have a lot of data to teach to the program, right? You have lots of these kind of emails to teach the program that this is the example of customer grievance or customer dissatisfaction. This is the example of the refund, etc. If you have thousands and thousands of emails, then you can definitely teach AI to how to do it, right? But the other thing that you cannot do is bring that kind of a personalization, which usually takes more than 1 second for you to identify, right? So that's I hope that gives you a very good understanding of what AI can do and what AI cannot do. And as everything in the world, right? This is a kind of an imperfect rule of thumb, but I have seen that this at least drive homes the point, right? Every time if someone has a sort of a confusion that what my AI project will or will not be able to deliver, comparing with this particular analogy will definitely help them understand what should be the depth of their AI project, right? So it's very important to understand that. Now, having said that, AI lately has transformed the way a lot of businesses perform, right? There are many business functions in each and every domain where a lot of data is available. What has happened in last few decades is the digitization of our society. Right? Every transaction that you are doing right now is digital, right? And that transaction is not only monetary, right? I mean, even in case of the customer grievance, 10, 15 years back, when you actually have a problem with a particular product, you will go back to the shop and you will, kind of argue with the shopkeeper that I didn't like this product, or this product has so and so flaw or something like that. And the shopkeeper will decide whether he wants to give you a refund or he will decide whether he wants to replace that item or whatever it is. Right now, you're sending an email, right? So that's, it's a kind of a digital transaction that you have. Even when you pick up the phone and talk to the person on the other side to raise your grievance, most of the time they tell you that this conversation is being recorded for training and experience perspective and stuff like that. What they are actually trying to do is digitize this entire transaction, right? Even in case of the recruitment, for example, right? There's a lot of, actually, it's a data-driven process. People will ask you to feed your resume in the system, then they will do an automated screening of the resume and things like that, right? So we have a lot of data about a lot of transactions, and each transaction sort of explains that what kind of the business function is going on in that particular business line, right? Even if you go to a doctor, right? The entire, you will register yourself, then you will show it to doctor. The doctor also will right now enter your entire case detail in the computer, what kind of medicine that he is giving you, what kind of symptoms that he is seeing, what is his prognosis and things like that, right? Even if he is giving you a handwriting prescription, most of the time those prescriptions can be taken a screenshot and sent it to AI system, where it will do a handwriting recognition and figure out which medicine that doctor is prescribing and things like that. So we have a lot of data, and if we can use that data, we can sort of bring artificial intelligence into a lot of business functions, right? So let me give you a couple of examples of business opportunities or the business functions that the AI has influenced. And these are all my first-hand experiences. Either I have read about them or I have practically worked in all these things, right? So nearly all the AI-enabled CRM applications, if you see Salesforce and all, they are providing the ability to do some sort of a pattern recognition where the sales team can find the highest potential new prospects, right? How they are doing it? Well, they are going through the series of attributes, the characteristics, and their specific values of a particular prospects. And depending on your previous experiences that you have fed into the sales system, it is trying to tell you that, when I look at this particular prospect, he has A, B, and C, and according to me, that should be your very high priority prospects, right? This entire process used to be manual earlier, but now, the sales team can open the dashboard and figure out which are the, top sales prospects that I should be targeting, and that kind of, driving their revenue, because now, instead of spending a lot of time in discussing something with, let's say, an intern in an organization, if they are directly talking with the CEO of a company, they are able to make more impact into that sales cycle, right? So the AI can figure out based on the attributes and characteristics that, the CEO of a company should be more, high priority prospects for you than, anyone else, right? The guided selling, right? So guided selling is progressing very rapidly. The Amazon is a very best example of this, right? If you buy a printer, immediately after a few days, Amazon will say, do you want to buy a refill for that, right? Or if you are buying something, the Amazon will immediately come up and say that, depending on your browsing history or depending on your previous purchases, I am recommending you to buy this, right? So that's what the example of the guided selling is. Flipkart is doing it, Amazon is doing it, a lot of other online retailers in US like Walmart, and in Australia there is a retailer called Woolworths. They all are doing this right now. And then if you are combining this historical selling, the price, and buying data in a single machine learning model, it will improve the accuracy and the scale of the sales forecast. Right now, the sales forecast that you used to do earlier was primarily dependent on a person's belief that this year is gonna go like this, and it's extremely biased because that's based on his personal experiences and all. But when you are combining all these things in a machine learning model, it gives you an unbiased view of what your sales forecast should be, and that definitely brings more accuracy into some of your business functions, right? So that's what that's what people do in sales using the AI. Even in manufacturing, right? You can use the AI vision models to identify the defects in the finished products, right? So you work for one of the manufacturing units who were preparing the nuts and bolts, and every nuts and bolts have a specific dimensions of the threads that they should have. If those dimensions of the threads are even off by the 1/10 of the millimeter, then the entire lot is rejected, right? So we can use AI vision models to identify, if there are any issues in the finished products. We can provide the automated visual inspections. One of the very good example of this is the wind turbine companies. So wind turbine companies have these windmills, the wind turbines in very remote locations all around the world. The accessibility is one of the biggest issue that they have, and the wind turbines are very, very long. I mean, they are like 150 feet high and things like that. Sometimes they are even 100 meters high. And on top of that 100-meter tower, there is a big fan, which there are blades which will turn as the wind blows, right? There is no elevator or anything. So if there is any defect in the blade, let's say there is a high wind and the blade cracked, if there is any defect, then the person will first have to go to that remote location, then go 100 feet, climbing. It's a vertical climb, by the way. It's not even, it's a 90-degree vertical climb, 100 feet up or 100 meters up. And then he will have to visually inspect where exactly the blade, crack in the blade is. The blade themselves could be 20 meters long, right? What the company started to do is they started to use drones, right? So now they go to the remote site and they fly the drones all the way 100 feet up. And the drones have the camera, and the camera takes the pictures of the blade, and they use the AI visual inspection to figure out if there is a crack in the blade or not, right? So a lot of progress have been made in this kind of automotive visual inspection also. Predictive maintenance is one of the other things that we used, where you can predict the failure of the machine even before it happens, right? As soon as your machine started to emit some sort of a vibration or acoustic or temperature fluctuation, the machine learning algorithm can immediately pick up and say, well, something like this happened in the past, and when that happened, 4 days after that happened, your machine was at completely breakdown. So you might want to take a look at right now. And that's what the predictive maintenance is, right? I mean, even today in cars, they will tell you that every 3 months you should change your oil, right? But I didn't drive my car in lockdown for almost 3 months. Do I still need to change my oil, right? So a lot of preventive maintenance has a lot of costs which are unnecessary costs. The predictive maintenance will tell me what is the viscosity of my oil, what is the temperature of my oil, what is the temperature of my engine, what is the vibration, what is the sound. And based on that, it can say, well, you don't need oil change right now. But the moment it starts smelling some abnormality, it will tell me that, in next 15 minutes, you might need engine oil change and things like that, right? Smart logistic optimization can definitely improve the automated replenishment process, right? Volkswagen plant in Bangalore, for example, makes these engines, the car engines. And one of the things that they use in the car engine is a very highly expensive engine oil. And that engine oil is very expensive. It's imported from Germany, and it takes close to 2 months for them to import. So they have to manage their entire logistic cycle to make sure that at any given point in time they have 4 to 5 months of reserve stock with them for that particular engine oil. Otherwise, they will have to stop manufacturing the engine in the Bangalore plant, right? If you use this kind of automatic logistic optimization, then you can bring more improvement, because every inventory that you have in your factory cost you something. And if you can reduce the inventory while taking care of the optimization, that will definitely help the overall bottom line of your manufacturing plant and things like that, right? Few other opportunities. Procter & Gamble uses machine learning to reach 4 billion customers personally. Procter & Gamble has a particular platform called One's Consumer Place. And if you go and check out, it's out in open. They tell you what exactly they are doing. The idea that the CTO had is that I have 4 billion consumers and I want to reach their life cycle, at a specific point in time. So if by machine learning, if there is a pattern in a buying which figure out that this particular household is buying a lot of pregnancy tools and stuff like that, the machine learning can identify that they are expecting a baby, what particular cycle of the pregnancy this particular family is, and according to that they recommend the products to them. Once the baby is delivered, they start recommending the diapers and stuff like that. But when the baby is 3 years old, they stop recommending diaper and they start recommending books and clothes and a few other things that baby need for cognitive development and things like that, right? So it's not that we are simply sending out an email saying there is a 50% off on your diapers. We'll send that email only to the people we know that who are expecting baby or who already have baby of that particular diaper age. And that actually makes a lot of difference when it comes to one-on-one connect between the consumer and the retail unit, right? You guys like Amazon a lot today because Amazon has personalized that experience for you, right? In agriculture also, a lot of AIs are being used. There is a company in Netherlands which is called AgriNavia, and AgriNavia use AI for a precision weed killing, and that in turn reduce the herbicides that they have to spray in their land. They can also do crop analytics and stuff like that. So the way they are doing is they take the photographs of the plants, from every 10 meters, and they identify the weeds using the artificial intelligence. And then based on what are the volume of the weeds that they have identified, they do a calculation of how much herbicide or pesticide is going to need, and according to that they feed that doses to their drones, and then their drones sprinkle that particular herbicide, right? And then they do the entire crop map analysis and things like that to see whether it actually made a difference or not, and if it has not made a difference, then they revise that particular calculations and things like that. And at the end of this, they document that entire treatment, that if this is what it is, then this is how you treat, and this is what it is, and this is how you treat, and stuff like that. AI is highly used in a medical science also. Right now we have a lot of medicines which are, kind of very generic. If you have a fever and I have a fever, then we both take a paracetamol and we get well, right? But that doesn't work in a very specialized disease like cancers and all. So what AI is actually doing is decoding your genetic profile and trying to figure out what kind of medicine will, what kind of medicine composition that we should be giving, which is specific to your particular disease and to your particular body, right? And things like that, right? So that's a personalized medicine. They also have done a lot of tracking movements to diagnose the cerebral palsy in the infants and things like that, right? So that's what, these are some of the ideas that you can get from what people are able to do in AI, right? All right. So what it takes to build the what it takes to make an AI project, right? So let's talk a little bit more about that. In a very generic sense, this is what we propose to any company, right? And these are some of the roles that we see that people are employing in artificial intelligence right now. So obviously the software engineer is definitely there. They build the specialized software to perform a specific task, right? So if you are building something like Alexa and say you want to write an application to tell a joke or to set up a timer or something like that, you need software engineers for that, right? So they write these specialized software to perform a specific task. But then you have something called machine learning engineers, right? So what they do is they write the models that they need to understand. So if someone is saying, "Hey Alexa," that's a model that machine learning engineer has to write, which is the speech recognition, right? So that's called a wake word, right? So wake word in this case is Alexa, and machine learning engineers will have to gather the data, develop and train the model, which will actually train the speaker so that when you say, "Hey Alexa," it will wake up and it will try to interpret what exactly is that you are trying to say, right? They gather a lot of data, like if they're working in a smart car, they gather a lot of pictures of cars and positions of car and movements and stuff like that. And they are very good mathematicians. They understand the statistics very well. They understand the linear algebra very well, and they build the deep learning algorithms, right? Usually their job is very iterative. They start with something and they just keep on revising and things like that. In many organizations, we have also seen machine learning researcher, and this is specifically true in cases of Google, Facebook, and all those things, where they take the existing machine learning algorithms that their organizations have developed and then they extend it. Most of the times, this is done for not for profit kind of a thing. So they just simply say, "Hey, we built this page rank algorithm, feel free to use that if you want to," or "We built this Hadoop system, feel free to use that if you want to," and things like that. And in some cases, it's even related to the patent, right? So if they are in Industry 4.0, Germany has a lot of machine learning researchers who have filed patent for automated the entire factory floors and stuff like that, right? So it's more kind of a research field where they always try to go one step beyond. They always try to think that what else can be done in the machine learning field, right? Then you have a data scientist, which sort of examines the data, provide the insight, prepare the business case for the CEOs and all the C-level people to say what is the current state of the company is and things like that. They do very little prediction though, because for that you need machine learning engineers to build the model and stuff like that. But they primarily work with data and kind of a business and provide the business intelligence. They they pick out the insights that your data says. So one of the terminology that we use is that they give you the information from the data, right? So the data is pure raw piece of scrambled piece of information, and then they churn out the knowledge out of it. They tell you what exactly this data is trying to tell you, and that's what the provide insight means, right? So these are some of the roles that we usually see in artificial intelligence and things like that, right? Then you have a data engineer which organize the data, who make sure that how the data will come into the system, how the data will be secure, how you can store the data cheaply, and things like that, right? And finally, you have an AI product manager who decides, what you can build, what is feasible, right? What is not. If you want to introduce a new feature, whether it is a valuable, valuable or not, and things like that, right? Okay. I want to finish this thing really quick. These are some of the AI pitfalls that we, from our experience, see people are doing, and these are some of the mistakes, right? And those mistakes are, some of these. And if you try to, if you can avoid these pitfalls, you will definitely be one step ahead than your competition, right? So what usually we suggest you don't do, you don't expect AI to solve everything, right? Instead, you be realistic about what AI can or cannot do, right? There are limitations to the technology, the data, even the engineering resources and everything. So don't expect that AI will solve everything for you. The other thing that you should not do is just hire only 2-3 machine learning engineers and count on them that, okay, they will take care of everything. They will come up with the business use cases also and everything. That is not true. You definitely need some sort of a blend, some sort of a mix of engineering talent with the business talent. You need to have that cross functionality figured out to find out, whether the projects are valuable to you or not, right? The other things that we saw people to do is, expect the AI to project to work for the first time. It doesn't happen. Even in Google and all those places also, it's kind of an iterative process, right? You need to have a multiple attempts to succeed. So don't expect that your AI project will, work first time, and don't get disheartened by that. I have numerous experiences where I have to train my model for multiple times before it can even send something meaningful, right? Also, don't expect your traditional software development methods to work without, significant changes. You have to understand the customized, workflows of the machine learning projects. And there is a specialized branch in DevOps, which is now called the machine learning ops, which takes into the accounts of the KPIs for the machine learning projects, because those KPIs are different than the normal, normal software development project. And finally, don't think that you need an AI superstar to start an AI project. You can definitely start something, small, and keep building the team and knowledge. After all, it's advisable that you start something small and fail rather than and succeed rather than you start something big and fail, right? So always start with something small, try to succeed in that, and then try to go and build something big, right? All right. So few other things. If you want to take your first step in AI, we suggest you bring a group. We saw that people people in the group motivates each other a lot. So get a group. Consider having a friend or someone. Ask them if they want to have a course with you, or or read the books, or prepare some sort of a training plan for you, and stuff like that. If you're already in that particular field, start brainstorming the AI projects, right? There is no project is too big or too small. As I said, it's better to start something small and succeed rather than start something very big and not succeed, right? If you are an entrepreneur, if you think that this is for you, you can start by hiring some ML or data science people to help you, right? You can also discuss with your your CEO if you want to go big. Whether you want to hire an AI lead, maybe a VP or a chief AI practitioner or something like that, right? You definitely need to discuss whether by doing this, this particular AI transformation, right, will bring the value to your organization or not, right? Whether it will be more effective for you or not, right? And finally, after all these 45 minutes of the session, right, this is a realistic view of AI, right? We don't want to be too optimistic, right? We are not going to have an AI killer robots or the Terminator kind of machines and all that's coming too soon. As I said, at least not in my life cycle, right? But we don't want to be too pessimistic also, right? We don't want to say that AI cannot do everything, so AI winter is coming. The AI winter is, kind of a term that people use to say, well, it's not, it's going to eventually die down and stuff like that. That's not the case. I think the more balanced approach is that AI can't do everything, but it will definitely transform the industry, right? So with that, we have seen many people, some technical, some non-technical, who definitely help their company to learn about AI and sort of start using it effectively. So I hope after these sessions and a few more webinars arranged by C-DAC, you will have a very concrete understanding, and you will be able to see what exactly AI can do and not. And you will definitely take the advantage of this knowledge to help your company or help yourself or even help others also. So thank you for your time today. And
thank you very much, sir. Yeah. Thank you. It was a great session, and the way you have covered the basics of AI, both perspectives of AI, and then the role of AI in different sectors based on your hands-on and own experience. It was a great enriching session. And now we would open for 2-3 minutes of question answer. Any doubts if any participants have related to AI and the role of AI in different domains? Any questions, participants?
Are they able to unmute themselves?
Yeah, sir.
Okay.
They are able to unmute. Or they can also ask on chat if someone wants to. Okay, no problem. Okay, then, sir, we will end the session here. And C-DAC, on behalf of C-DAC Patna, I feel great to have you as an expert speaker. And the way you have designed your talk was, I think it would be great for all the participants and including me. And thank you for the session, sir. For the information of participants, as sir said, in this series of webinars, we will have the next in line webinar series by Dr. Sandeep Raj from IIIT Bhagalpur. Tomorrow at same time, same link. And his talk would be on AI for healthcare, where he is focusing on AI methods for development of monitoring devices, ECG monitoring devices. Okay, then we will end here, sir. Thank you, Kunal, sir. Thank you for your time.
Thank you, Saket. Thank you, everyone.
Thank you, sir.